Okay, we're going to do lesson 3.4. During this time, you will need to take notes in pages 137 through 141 of your book. As you fill these in, please pay attention to all the concepts. Once we're done, you will tear these pages out, staple them, put your name on it. At the end of class, you will turn these in. During time when you have to work on your homework, you can use these pages as a reference to help you get through the homework. Just make sure you turn these notes in at the end of class to Mr. Smith. Okay, so let's start. Let's talk about first, what is domain? So when we look over here, domain is the set of input values or X values. We also refer to domain as our independent values, independent. So there are X's, it's what we're plugging in. Our range is the set of corresponding output values or Y values. It's what you get after you plug in values into a function. So in this particular example, it asks us to graph the function for a given domain. So graph the function for this given domain. The big D here represents domain. So we have 4 values for domain. Before we graph them, we're changing the equation into slope-intercept form. Y equals mx plus b. So they've given us steps to do to change the function. The first thing they do here is they subtract x from both sides. So as you subtract x from both sides, you end up with 15 minus x on the right. Next, you have to get rid of the 3, so you divide by 3. So on the top, we have 15 minus x divided by 3. So what we're going to do is we're going to split this portion up into 2 different fractions. So we get 15 over 3, and we also get plus a negative x over 3. So we're going to simplify that. 15 over 3 is 5, plus we can write negative 1/3 x, since a 1 is here in front of the x. Even though it's not written, we know it to be there. So now we have our function written in slope-intercept form. Y equals mx plus b. We just have reverse order here. So as you can see, they have the function here, y equals negative 1/3 x plus 5, whereas we had it reversed, still the same thing, just in a different way. So now we take our domain values that were given to us at the beginning, the first one being 0. So we plug 0 in for x, which is what they've done right here. And we go ahead and simplify. Anything times 0 is 0, 0 plus 5 is 5. So we end up with the point 0.5. Okay, so we continue, we put 3 into the function, so we substitute 3 in. Negative 1/3 times 3 would be negative 1. Negative 1 plus 5 is 4. So now we end up with the point 3, 4, since that is our x, and these are our y's on the right. So we continue the process. We plug 6 in, which they've done. Negative 1/3 times 6 is negative 2. Negative 2 plus 5 is 3. So we get the point 63. And then we plug the point 9 in. If we plug 9 in, it goes here. Negative 1/3 of 9 would be negative 3. Negative 3 plus 5 is 2. So now we have the point 9, 2. So since this is a linear function, there should be patterns that you notice. If you look, our x's are going up by 3 each time, and our y's are going down by 1 each time. So all we're left to do here is plot the points on the graph. So we plot the point 0.5. Pay attention to your scale. Again, right here in this particular graph, each line is a value of 2, not 1. So as you plot the points, be aware of that. So we have x is 0, y is 5, so that's going to be right here in the middle. Then we have x is 3, which would be in the middle between 2 and 4, and then up 4, so we're right there. Then we have the point 6, 3, and then we have the point 9 and 2. And the final thing to recognize here, this is a discrete function. We've talked about discrete. You're not connecting these points because our domain were each independent point of a value of 0, 3, 6, and 9. It is linear, however, we are not connecting them because it is a discrete function. So now we look at these reflect questions, and that's what we just talked about. Why do you not connect the points of the graph? Because this is a discrete function, and our domain were just the values 0, 3, 6, and 9. So you do not connect the points because we're not including any of the values in between. How would the graph be different if the domain were 0 less than or equal to x less than or equal to 9? Well, then we're including every value that is in there. So now if we were going to write the range of this function, our range would now be every value between 2 and 5. Because when we first did the function, we had 0.0369. Our y values went from 5 to 2, but now it would be inclusive of every value in between, not just each individual point. So for example 1a, this is a different function because this one is not a linear. It has x squared. We call this a parabola. This is called a quadratic function, and it forms a smooth curve. So we're still looking for points in order to connect them to make a curve. The difference for this one is our domain is all real numbers. We don't have a set domain for this particular function. It just says graph and gives us a function. So we need different values to determine this. A great tool here would be your calculator. If you go to y equals, type in your function x squared. Then if you press second window, it's called our table set. Look for your independent, have it on auto. Your dependent, which are your y values, have also on auto. Then if you press second graph button, which is the table, it will generate a table of values. And what we look for here is where there is a repeated pattern. In other words, here at 0, the value is 0. At -1, the value is 1. But also at 1, the value is 1. There's a repeated pattern. 1, 1, 4, 4, 9, 9. On your calculator, where you see those repeated values is where you would choose those points to plot and graph. And that's how you get a curve, because you have -1, 1, +1, 1, -2, 4, +2, 4, and it generates this parabola or this curve. So I always tell students, use the calculator, go to your table, use the table to find where the pattern repeats itself. So you look at your x's, but you're looking at the y's to find where the pattern repeats. 9, 4, 1, 0, 1, 4, 9, a repeated pattern. So now we're going to work this example B, which again is a linear function, so it's a little bit easier. It is using function notation, f of x. All f of x means is y. So when you're looking at function notation, y is f of x. The only reason we use function notation is that sometimes it's easier to denote what value to plug in. So if I have function notation and I have, in this case, f of -1, that means I'm plugging -1 in for x into the function. It still is just y. Now at this point you could also use the calculator. Go to y equals, so instead of f of x, go to y equals, type in your function, 3x minus 5. Go to second graph, go to the table of values, find where x is -1, and then immediately you should see what the y value is beside of it. And then you can input those here. We're going to just go ahead and fill these out very quickly here for each of these. So here we have -3 minus 5, which is a -8. Here we're plugging 0 in for x. So you have 3 times 0, which is 0. 0 minus 5 is a -5. So we'll fill these points out on the right as well. Here we're plugging in 1. 3 times 1 is 3. 3 minus 5 is negative 2. So this is negative 2. And again, since this is a linear, you should see a pattern developing, and we'll look at that pattern once we finish all these. So we put 2 in for x. 6 minus 5 is 1. Here we have x is 3. 9 minus 5 is 4. And finally, we have f of 4, so we plug 4 in for x. 3 times 4 is 12. 12 minus 5 is 7, so we have the point 4, 7. So again, clean this 4 up a little bit here. We look for the pattern. Our x's here are increasing by 1 each time. Our y's are increasing by 3 each time. Now again, this only occurs in this way if it is a linear function, a line. So now that we have our points, we want to plot these points from the table on the graph, and then we want to answer these questions. So we go ahead and plot the points on the graph. Now again, since this is a domain of all real numbers, this will be a continuous function. So I have the point, again, our scale here is 2, -1 and -8. And then I have 0 and -5. Now I have 1 and -2, and 2, +1, 3 and +4, and then finally 4 and 7. So again, they make a straight line. We're going to connect those. My line's not very straight. I put arrows on both ends to indicate that this function continues. So our questions here, the points appear to form a what? They form a line. So it says draw a line through all the points to show the ordered pairs that satisfy the function, and draw arrows on both ends of the graph. So to continue here, our reflect question. When graphing a function, does it matter if the function is written in function notation? Explain. It does not matter if it is in function notation. What you need to remember is f of x is function notation, and that is the same thing as y equals. The only difference is for function notation, it allows us to see exactly what value we're plugging in for x. Now at this point, you're going to go ahead and try the your turn problems. I'm going to give you a second, and then I'm going to put the answers on here so that you can check those. Okay, so now you can check right here. This is a quadratic again, forms a parabola, a smooth curve. Again, I would encourage you to go to your table on your calculator, put your function in as y equals -x². Then go to your second graph table, look for values. Again, look for that repeated pattern. Here, -1 has a value of -1. +1 has a value of -1. Look for where those y values repeat, plot those points, connect your curve. You could also do the same for this one to get points. Go to y equals, type in your function, -4x + 2. Look at your table of values to get points, plot those points, and draw your line. Again, pay attention to your scale for both these graphs. They have a scale of 2. All right, so I'm going to quickly look at example 2a. Again, this is worked out for you. I want to show you a little difference here. The book asks you to use the trace button on your calculator to find this. Instead, what I would suggest to you is to either go to, again, second, the graph button, and look in the table. So you look in the table for where x is -2, and then right beside of it you should see the y value that says 4. As long as you have this function in y equals in the calculator. If the function's not in there, you cannot find it. Another way to do this particular problem without necessarily using the table is to use instead the calculation button. So another way to do this is to go to second trace button, and then number 1 under that menu says value. And if you press that, it's going to take you to the graph, much like this. But right here, it's going to say x equals blank. And at that point, you type in -2. You press enter, and then on this side, right up here where it says y equals, it'll bring up the value of 4. The limitation to using this method is that if your graph does not include the x point, if your window is not big enough on the calculator itself to include -2, then it will not give you the value. Okay, so now we're going to do example B. So it says first graph the line. So at this point, you could use a table of values, but I'm just going to use the slope-intercept form itself. That is my y-intercept. So I start at -4. So I go to -4 and I put a point. Then I use my slope, which is 3/2. Remember, slope is rise over run. So I go from my starting point, my y-intercept, and I'm going to go up 3. Now, since these are by 2s, there's 2, there would be 3. So it's rise over run. My run here is a +2, so that means I go to the right 2. So then I go to the right 2. Again, since this is a scale of 2, that would put me right here, and there's a second point. And again, I could repeat this process. This time I'm going to go backwards, because remember, we've talked about before how slope, even though right here it's 3/2, could also be thought of as -3/2, because 2 negatives make a positive. So now I start from my y-intercept and I go down 3, and then I go to the left 2 and get a second point. Whenever you're graphing a line, you always want at least 3 points to draw your line. So now I have the 3 points. I'm going to draw the line. Now, I'm not using a ruler. I would suggest to you to use a ruler so that you can find the values. So in this case, it says we want to locate -2 on the x-axis. So if I locate -2, that would be right here. It says draw a vertical line segment from -2. So we find -2, which is right here, and we draw a vertical line segment. Vertical means up and down, so we go down. So this blank is -2. And then what we want to do is we want to draw a horizontal line, which is left to right, where it intersects the function. So at this case, we're drawing right here. So really all we're doing is trying to locate this particular point, which we found by using a separate definition of the slope, -3/2. So the value of the function there is actually -7. Now again, you could use the calculator here to find the value by either using the table, or you could go again to the second trace, number 1, do value, as long as your window's big enough to see it on the graph. So now I want you to try to do your turn problem, number 6, to use a graph to find the value when x is 3. Again, I would suggest using some sort of straight edge to draw your line so that you find the value. And I'll give you a few seconds here to do that, and then we'll check it. Okay, so what I've done here is I've gone ahead and drawn the function. Again, I started with my y-intercept of 7. I have a slope of, this is actually -1/1 or 1/-1. 2 ways to think about it. I used both. If I do -1/1, that means I go down 1 and over 1. That's how I got that point. If I use 1/-1, then that means I go up 1 and to the left 1, and how I got that point. Then I drew my line. I drew a vertical line at x is 3, found where it got the function, then drew a horizontal line across, and that is at the value of 4. So for this particular problem, the value of the function when x is 3 is f of 3 is equal to 4. When x is 3, the value of the function is 4. Okay, so our final example here is a word problem. We're going to read through here. The Mid-Atlantic separates the North and South American plates from the Eurasian and African plates. The function y equals 2.5x relates the number of centimeters y the Mid-Atlantic ridge spreads after x years. So this is important. Y right here is centimeters. That's our distance. X here represents years. And since this is a word problem, we'll need to label our axis accordingly. Okay, it says graph the function and use the graph to estimate how many centimeters the Mid-Atlantic ridge spreads in 4.5 years. Now the good thing is on a calculator you can find the exact value. Here we're just guesstimating using the graph that we're going to generate. So the function y equals 2.5x describes how many centimeters the Mid-Atlantic ridge spreads after x number of years, depending on how many years it is. So here we want to only use positive values for x and y, because again, x here is years. We can't have a negative number of years. We just want positive numbers. So since we're putting positive values in for x, then if I look at my function itself, then I have to get positive values for y as well. So it says use a graph to find the value of y when x is, in this case, we were looking at 4.5 years back up in the problem itself. So now we're going to use our equation to generate points in the table. So I've already gone through and filled in the table for the values, just repeating the same process we've done before. Again, you could use the calculator, just making sure you put the function in y equals, go to your table, look at the values 0, 2, 4, and 5, and it'll generate the y values 0, 5, 10, and 12.5. I've plotted my points over here. Things to point out. I only put an arrow on this end because, again, remember, we cannot go into negative values. Other things to pay attention to. My scale. Since my function is 2.5x, that means my y is going up by 2.5 each time. So here they used a scale of 2, whereas my x-axis is going by ones since they represent years. Always label your axis, what they represent, and the units in which they're represented. Time is in years. The distance spread here was in centimeters. So now we're going to try to answer our questions here. Fill in the blanks, draw a line through all these points because the points appear to form a line. Now technically it's not a line, again, because we don't have an arrow on this end, just the other end, but still forms a line, what we call in geometry a ray, because it only has an arrow on one end. And it says use the graph to estimate the value, y value when x is 4.5. So again, if I go right here to 4.5 and I go up, so using the vertical line, so I'm going to draw a vertical line here from 4.5 and go up. And if I go up, I get right here on the graph. So I go straight across again, draw a horizontal line across, and you see it's a little bit higher than 11. Now there's no way to know exactly from our graph because our graph goes by twos. I know it's a little bit more than halfway, so I know it's a little bit more than 11. And again, this is where your calculator would be helpful. The problem on the calculator, again, is our values are probably going by ones. So if you go to second table set, change your independent to ask, then go to second graph to your table, it will then ask you what you want for x. So then you type in 4.5. When you do so, it'll give you y1 equals, and then it'll say 11.25. So that's our value here is 11.25. Again, the calculator can be precise, whereas if we are actually using the graph over here, we can only do a guesstimate of what the value is. So to continue with this problem, the distance of the Mid-Atlantic ridge spread increases, gets bigger. So the spread is growing as the number of years increases. So the graph is a reasonable representation. When x is between 4 and 5, y is between, okay, and then this is where we can get guesstimates. So it's between 10 and 12.5 because we calculated those particular values in our table. So since 4.5 is between 4 and 5 as far as our x values, then it's reasonable to estimate that y would be in the middle of 10 and 12.5. So if we take the middle of that, then that's where we get 11.25. Again, using the calculator would tell us exactly that value. So here's a your turn problem again that I want you to try. I'm going to wait here and pause. While I pause, I'm going to actually be working this, and then I will show you the answer to the your turn. Okay, so I've given you a little bit of time here. So I filled out the table. I did not write the equation in here. I just went ahead and showed you the first example because now we've done plenty of these. I used the value 0, 1, 2, 3 because again we're talking about positive values, time being in hours. You cannot have a negative number of hours. So I use 0, 1, 2, and 3 here to get points to draw my line. So I got my 4 points, plotted all 4 of those points on the graph, drew again, not technically a line, but a ray because it only has an arrow on one end. Then it asked me to determine how far it would be 2.5 hours from now. So I went to 2.5. I drew my vertical line till it got to the function, drew a horizontal line across, and I see it somewhere between 40 and 45. Now technically, again, if you go on the calculator and you put the function in the calculator under y equals and go to your table and put it on independent on ask and put in 2.5, you can get the exact value, which in this case, for this particular problem, when x is 2.5, y is actually 42.5. Now, again, what are we talking about? We're talking about 2.5 hours. Go back over here and look at our x-axis. Also look in the problem, x is in hours. And also 42.5 kilometers. Again, we can look over here at the y-axis and also look in the problem itself. So always make sure that you try to include your units as you're answering questions. So finally, I want to look at these elaborate questions. Is it enough to plot 2 points to see a pattern for a graph? No, it's not. 2 points only gives you 2 points. To see a pattern, you need 3 or more points. Typically, I recommend to students at least 5 in order to see a pattern. When you use a graph to find the value of a function for a specific value of x, do you always get an exact answer? And we just found out in the 2 examples we worked, no you can't, because your scale may not be as precise, so you can't always get an exact. That's why we use the calculator as a tool to find those values. How do you graph a function that has a domain of all real numbers? Again, you use several ordered pairs. Again, I would recommend at least 5 to see that pattern, to see whether it's a straight line and or a smooth curve. To connect those, make it a continuous function and put arrows on the end. Now you're going to work on the homework, which is going to be on your Google Classroom. So if you go back and look at your instructions for Google Classroom, you'll see what your homework assignment is, which are problem numbers 1 through 16, all, and 17 through 23 odd. So for the remainder of class time, you need to work on the homework. You can use your notes as a reference. Remember, by the end of class, you need to tear these pages out, put your name on it, staple them together, and turn them into Mr. Smith as an in-class note assignment.